Start. Hello everyone. Today is day 16 of our 30 days 30 machine learning projects challenge. Uh, so let's start. Today we are going to do something different. We will be doing a real time face detection in a webcam using uh, OpenCV. I have never done this. I come from a Drupal background, a PHP background. I know about Java also, built Java projects. But yes, this is going to be an interesting day. So I'll say, hey, today is day 16, and here is the problem title. Let's say what it has to reply. Okay, it got stuck. Okay, so let me send it again. And now the model should be working. I guess the context has become too long. That is why it is getting stuck again and again. So I don't know, maybe today also, if it is going to happen, we'll start in a new window and provide the previous context. So yes, let's start. Great, let's get started with today's problem: real time face detection in a webcam using OpenCV. Here's how we can approach it. We have to install the OpenCV Python, load the pre-trained HAR cascade for face detection, capture the video using OpenCV's video capture, detect face in real time, and terminate the feed. I don't know how. Okay, it looks good. So what we have to do, we have to first install this, uh, and then we have to install OpenCV Python. It is installing, so let's wait a while, and then we can read the further steps. Make sure you have OpenCV Python installed. If not, you can install it using this command, and that we are doing. Load the pre-trained HAR cascade for face detection. OpenCV provides a pre-trained face detector in the form of HAR cascade. Um, we will use HAR cascade. So it provides a pre-trained face detector called as HAR cascade. So we will use this. Capture the video using OpenCV's video capture. So it is, I guess it has a class or a package. So we will be using it to capture the video. Use HAR cascade to detect faces in each frame of the webcam feed and draw rectangles around them. Okay, cool, interesting. We will see what it is. And then safely close the video feed when user exits. So when we will exit, it should safely close the video feed. Um, so yeah, let's start. It has completely installed. So let me create a new file for today, day 16.py. Add it to our git repository, and in my comment section, let's mention what it is. The problem is, let me copy and paste it. So let's start. uh, we have to import cv2, the OpenCV. Step number one here. Step number one is load the pre-trained HAR cascade for face detection. Okay, load the pre-trained detector called as HAR cascade for face detection. So I guess we are not doing anything creative or new here. We are trying to understand how it works. So it is a great problem, I guess, to get into the face detection world. So we say face cascade and cv2 dot cascade cascade classifier, and here we say cv2 dot uh, data dot har cascades, cv2 dot data dot har, is it correct? Not cv2 data dot har cascade. I guess it is going to throw the error. Let's copy and paste the name of this file and paste it. Let's run it, and I guess we will get the error. Oh, we did not. Strange. Let's do what? Let's go to the step 2. If when we'll get the error, we'll come back to this step. Step 2, uh, capture video from the webcam. So, uh, capture video from the webcam. Okay. So it is going to be capture cv2 dot video capture. Okay, and we'll zero it. Okay, and then step 3, process each frame of the webcam feed and release the capture and close the OpenCV window. So let's uh, s- run step 5 first, because I'll test it right away. I'll not wait and perform this step number 3 and 4, because we need to understand what is happening. But I do want to test whether this step number 1 and 2 are working. So for that, after doing that, we need to close the session also, right? So for that, we need to release the OpenCV window. So for that, we will do step number 5, release the capture and close the OpenCV window. Release the capture and close the OpenCV window, and it is going to be capture dot that capture window that we have started. Release it, and uh, then we have to do destroy all window. Let's run it. Give me a second. Let me uh yeah, I have a cat here, so let me give. mm, so let's run it. It says allow. I say okay. I don't know what has happened. I'll go to this window. I can see. Oh, so it did. If you see, I mean, you can obviously not see because I'm recording the screen, but it did turn on the webcam, because I did see the green light around my webcam. So it did work. Let me run it again and see. It turned it on and turned it off. Nothing has happened. So yes, let's write the other code and see what are we doing with the rest of the code. Step number 3 and step number 4. So step number 3 is process each frame from the webcam feed. Step number 3 is process each frame from the webcam feed. And what are we doing here? So we are running while 2. It is looking like an infinite loop. We are reading the each frame. So what we are doing, reading the each frame by rate frame, and we are doing cap dot read, and we are doing read each frame. um, Let me see. I'll ask the code you gave, can you explain it, uh, it its each line in detail? Okay, so it says we are importing the required library. This imports the OpenCV library. We understood that. Here, what we are doing, we are using this cascade function to loads the pre-trained R cascade XML file, which contains the model for detecting the faces. So we are loading the pre-trained model for detecting the faces. OpenCV comes with several pre-trained models for face detection, and here we are using the R cascade frontal faced default.xml model. Then we are specifying the directory where OpenCV stores its pre-trained model, so the cascade file can be located easily. Okay, so this is the location of the pre-trained models, and this is coming as not nice for us, as in it has a yellow underline. And this is the XML file that contains the R cascade data for detecting human frontal faces. Okay, understood. For human frontal faces, this is the name of the file. Now we will capture the webcam. This creates an object cap which starts accessing the webcam. The parameter 0 specify that the default webcam, if you have more than one camera, which is 1 2 3, and there are more cameras, so we will go ahead with the default one. That is why we are passing 0. The webcam is now ready to capture. That is why the moment I'm running this, it shows it, the webcam got turned on. And yes, then step number 3, this is the step, actually the meat, the crux of the whole problem. Process each frame from the webcam feed. While so what we are doing, while true, this starts an infinite loop, as I was saying, that continuously processes the video stream frame by frame. Okay, now this, what it is doing, this reads the current frame from the webcam. Okay, the read method returns true value. So this read method returns true value, ret, which is a boolean that indicates whether the frame was successfully captured or not. Ret is that a boolean value, whether to show that whether the frame was successfully captured or not. Then frame, the captured frame. Okay, if not ret, if it was not captured, it means that there was an issue capturing the frame. So break the while loop. Okay, so I'm going to paste it here. Okay, it's okay. So this is going to be okay. And if it will return true, so if it will have false, so break the while loop. So for that, we are doing if not red, which is, if it is false, then it will come in the if statement and then break the loop. So this will make sure that we are not entering a while loop. So let's run it. It should turn the webcam, and it is in the oh, it did not turn off. So it is in the infinite loop, and if I close it, will it turn it off? It is not turning it off. So let me go and read the other statements. Convert frames to grayscale. Okay, so we are going to use these to convert the okay, yes, sorry. So convert the so this converts the captured frame from a colored image to a grayscale. Face detection using hard cascade performs better on grayscale images because they are computationally less complex. Okay, so it is, we are using hard cascade, and it performs better with the grayscale images because they are less complex. So we will convert it into grayscale. So what we are doing, is it inside the while loop? It should not be. It is inside the while loop. Convert the image into grayscale as R cascade performs better with less complex uh, grayscale images. Okay, so what we are doing, gray, and then we use cv, open cv, convert to color, and we here we pass the frame that we have captured, and what color we specify color, background to, no, we specify color background to gray, color bgr to gray, color bgr to gray, color bgr, yes. Now step number 3 is, step number 4 is what, we'll go back to the detail. Yes, step number 4 is detect faces in the frame. Okay, so yeah, let me pause because I want to make sure that it is recording. I don't want to, yeah, okay, if it, even if it is not recording, that is not the intent of me recording, right? So yes, okay, so it is face cascade detect multi-scale. So this problem detects whether objects, in our case faces, in the grayscale images, so okay, it detects the object, that is faces in our in this grayscale, so it detects those. It returns a list of rectangles where the faces are detected. It returns, okay. And now parameters, gray is the grayscale images. We specify scale factor, which specifies how much the image size is reduced at each scale. 1.1 means the image is reduced by 10% at each scale. Okay, minimum helping to detect faces at different sizes. Okay, min neighbor, specify how many neighbors each rectangle's candidate should have to retain it. Higher values result in fewer detection than the higher quality. Okay, I do not understand, but maybe in future problem we'll understand more about it. Min size, the minimum size of the detected face, minimum possible size of the detected face, any smaller size is going to be this size. Okay, and then we are going to draw it, and then we are going to show it, and then we are going to exit it. So let's go detect the faces. So what we are doing, detect the faces in the frame. Okay, so what we are doing, we are detecting the faces using which, face cascade. Face cascade we had created in step number 1. The pre-trained model, the object of pre-trained our cascade model, using its detect multi-scale function. Here we are specifying which image we want to capture, the grayscale image. Here we are saying scale vector is 1.1, and then we say minimum min neighbors are 5, and then the minimum size of the face is going to be 30 30. Let me, I don't know if it is going to consider my face as the minimum or not. Now let's draw rectangles around the detected face. So we are going to do what, draw rectangles around around the detected faces. So what will so in a screen there can be multiple faces, so it is going to draw the rectangle around them. So what we are doing, we are loop through all the detected faces. Each face is represented by a rectangle worth xy wh, where xy are the top left corner of the rectangle. Okay, wh are the width and height of the rectangle. Okay, okay, understood. uh, so we will draw using the rectangle function of OpenCV. Draws a rectangle on the original colored frame. Okay, and these are the dimensions, and it specify the rectangle color in background, that is blue. It specifies the background color, which is blue in our case, and this is the thickness of the rectangle. Okay, so let's do this. X Y, the top, yeah, the top left corner of the rectangle, the width and height in faces. And what we are doing, we are going to draw them using rectangle function. It is going to be the original frame image. the x and y coordinates, and the bottom coordinates, which is x plus w, y plus h, top left and top right corners. And this is going to be the background image. Background image in our case is going to be blue, so it is going to be 12 255 0 0, and then the thickness of the rectangle is going to be 2. And then what we are going to do, we are going to simply show the detected faces. Display the frame with detected faces. Display the frame with detected faces. So what we do, we will run it. cv2 with function I am show, to show the detected faces. uh, we'll say face detection, and we will do frame and exit the loop. Now let me see, where are we at? Is it still under the for loop? No, it is outside the for loop. Okay, then what we are doing, we press q to exit the base cam, sorry, webcam feed. Okay, so we are mentioning, so if you would have run, I mean, if you don't know actually, so the webcam is still on, even though I have exited from the running this code here. See, so I have suspended it, so it is still running, so we have to specify how to exit from it. So we are doing press q, press q to exit the webcam. Press q to exit the webcam. So what we are doing, if cv2 wait key, wait key is 1, and let me go here what it says. Yes, this function wait for the press key for 1 millisecond. Okay, so it waits for the press key for 1 millisecond. 1 millisecond delay is needed to give OpenCV time to refresh the window showing the window. Okay, it waits for waits for a key press for 1 millisecond. Okay, and this ensure compatibility across different operating system. Okay, so it ensures compatibility between different operating systems. So mine is Mac. So yes, and this is going to be q, and this checks if the q key was pressed, if it was loop breaks, and then the program ends. And it checks if the q key was pressed across different operating system, then wait for the OpenCV to refresh the window, how, 1 second, and then break. Okay, correct. Here it is not, termination is not required. So let's run it again. And I do see, say overload release resolution. So it says line on line number 19 I have a problem. Here I have a problem. Okay, I don't think I need this. So, oh, see, it is recording. So yes, I can see the faces. I don't have more people in the room, so I'm unable to show. So yes, this is how it is working. Let me move. Okay, it is detecting something here, I mean these here. So let me move and see if it is working fine. Yes, yes, it is working fine, it is working fine. Yes, if I move here outside, yes. So I'm really happy how it is going. I don't know if the voice is coming nice or not, but yes. So this is the let me I don't know. Let me press Q, and it did it did work. I'm really happy actually. I always wanted to build something like this cool, and I built it thanks to this challenge. So yes, we have successfully built our first OpenCV program, and I'm really happy. I cannot tell you how happy I'm feeling. So yes, let's commit this code. Commit let's do status, add day 16. Let's commit this code, add code for day 16, and then push. Okay, and I'm going to go here, and then we'll see in the git file. I guess I must have mentioned somewhere that yes, let me go to the git repository, and I should be seeing the day number 16, and here it is. So thank you everyone for staying this long on day 6. We'll come back and solve the day 17 problem tomorrow. Thank you very much.